There are no restrictions in the National Electrical Code, or NEC, for emerging from the top of electrical gear to feed another load. The use of bonding bushings is acceptable, provided they are listed for the specific application. To further clarify this, let's delve into the relevant aspects of the NEC that govern such installations and ensure compliance with safety standards. Firstly, it is crucial to understand the general requirements for electrical installations as outlined in Chapter 1, Articles 100 through 110 of the NEC. These articles provide the fundamental definitions, rules, and regulations applicable to all electrical work. Secondly, Article 300 addresses wiring methods and materials. This section details the approved methods for installing conductors and cables, including the use of electrical metallic tubing or EMT. It specifies the conditions under which EMT can be used, the requirements for supporting and securing it, and the proper methods for making connections and terminations. When considering EMT as a raceway for conductors exiting the top of electrical gear, you must adhere to these guidelines to ensure a safe and code-compliant installation. Thirdly, Article 250 focuses on grounding and bonding. This is particularly relevant when using bonding bushings. Grounding and bonding are essential for minimizing electrical shock hazards and providing a low impedance path for fault currents. Bonding bushings are used to ensure effective bonding of metal raceways, such as EMT, to the metal enclosure of the electrical gear. This is necessary to maintain electrical continuity and provide a safe path for fault currents to return to the source. The NEC specifies the requirements for bonding metal raceways and enclosures, including the proper selection and installation of bonding bushings. Bonding bushings must be listed for the application, meaning they have been tested and certified by a recognized testing laboratory to meet specific performance standards. The listing ensures that a bonding bushing is capable of providing a reliable electrical connection and can withstand the expected fault current levels. When installing bonding bushings, it is important to follow the manufacturer's instructions and the applicable requirements of the NEC. This includes properly cleaning the surfaces to be bonded, applying an antioxidant compound to prevent corrosion, and tightening the bushing to the specified torque. Furthermore, the bonding conductor must be sized appropriately based on the size of the circuit conductors, as specified in NEC Table 250.102. C1. Also consider the specific requirements for switchgear installations found in Article 408. This article covers the construction, installation, and use of switchgear, switchboards, and panel boards. It provides guidelines for the location, arrangement, and protection of this equipment. When routing conductors from the top of the switchgear, ensure that you maintain adequate clearances and separation between conductors, as specified in Article 408. Additionally, the switchgear must be properly grounded and bonded in accordance with Article 250. The metal enclosure of the switchgear must be connected to the grounding electrode system to provide a low impedance path for fault currents. This grounding connection must be made with a conductor sized according to NEC Table 250.122, based on the size of the largest overcurrent protective device in the switchgear. The NEC also addresses the use of supplementary overcurrent protection in Article 240. If the conductors exiting the top of the switchgear are supplying a load that requires additional overcurrent protection, you must provide suitable fuses or circuit breakers at the point where the conductors originate. These overcurrent protective devices must be sized to protect the conductors and the equipment they supply, in accordance with NEC Table 310.16. Ensure that the conductors are properly supported and secured in accordance with Article 314. This article provides guidelines for the installation of boxes, conduit bodies, and fittings. The conductors must be supported at intervals specified in Table 314.23 to prevent strain on the terminations and to maintain the integrity of the wiring system. Consider the requirements for working space around electrical equipment, as specified in Article 110. This article mandates that sufficient working space be provided around electrical equipment to allow for safe operation and maintenance. The working space must be clear and unobstructed and must meet minimum dimensions for width, depth, and height, as specified in Table 110.26. These dimensions vary depending on the voltage of the equipment and the location of any exposed live parts. Also consider the requirements for conductor ampacity as specified in Article 310. This article provides guidelines for determining the allowable ampacity of conductors based on their size, insulation type, and installation conditions. The ampacity of the conductors exiting the top of the switchgear must be sufficient to carry the load they supply without exceeding the temperature rating of the insulation. The ampacity of the conductors must be adjusted for ambient temperature and the number of conductors in a raceway in accordance with NEC Tables 310.15, B1 and 310.15, B3. Furthermore, consider the requirements for cable and conductor identification as specified in Article 310. This article mandates that all conductors be clearly identified to indicate their purpose and voltage. The identification must be durable and resistant to environmental conditions. Conductors can be identified by color coding, marking tape, or other approved means. The grounding and bonding conductors must be identified with green insulation or green marking tape. The ungrounded conductors must be identified with a different color, such as black, red, or blue. When installing conductors in EMT, ensure that the raceway is properly reamed to remove any sharp edges or burrs that could damage the conductor insulation. Use a conduit reamer or a deburring tool to smooth the ends of the EMT before pulling the conductors. Also, use a pulling lubricant to reduce friction and prevent damage to the conductor insulation during installation. The lubricant must be compatible with the conductor insulation and the EMT material. When making connections to the switchgear, use only listed and labeled connectors and fittings. These connectors must be suitable for the type of conductor and the size of the raceway. The connectors must be installed in accordance with the manufacturer's instructions and the applicable requirements of the NEC. Tighten the connectors to the specified torque to ensure a reliable electrical connection. Furthermore, when installing EMT, ensure that the raceway is properly supported and secured. Use conduit clamps or straps to support the EMT at intervals specified in Table 344.30. The support must be securely fastened to the building structure or the switchgear enclosure. The EMT must be installed in a neat and workmanlike manner, with all bends and offsets made using approved conduit bending tools. Consider the requirements for voltage drop, as specified in Article 210. This article recommends that the voltage drop on branch circuits not exceed 3% to the farthest outlet for power, heating, and lighting loads, or 5% overall for feeders and branch circuits combined. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. To minimize voltage drop, use conductors of sufficient size and keep the length of the circuit as short as possible. When installing conductors in parallel, ensure that all conductors are of the same size, length, and insulation type. The conductors must be installed in the same raceway and must be terminated at the same point. The overcurrent protective device must be sized to protect the parallel conductors in accordance with NEC Table 310.16. Furthermore, consider the requirements for hazardous locations, as specified in Articles 500 through 516. If the switchgear is located in a hazardous location, such as a flammable or explosive atmosphere, you must comply with the additional requirements for wiring methods and equipment. Hazardous locations are classified into different zones based on the frequency and duration of the presence of flammable or explosive substances. The wiring methods and equipment used in hazardous locations must be approved for the specific zone in which they are installed. Consider the requirements for healthcare facilities, as specified in Article 517. If the switchgear is located in a healthcare facility, such as a hospital or clinic, you must comply with the additional requirements for wiring methods and equipment. Healthcare facilities have special requirements for grounding, bonding, and emergency power systems to ensure the safety of patients and staff. Consider the requirements for emergency systems, as specified in Article 700. If the switchgear is part of an emergency system, such as a backup power supply for essential loads, you must comply with the additional requirements for wiring methods and equipment. Emergency systems must be designed to provide a reliable source of power in the event of a power outage. The wiring methods and equipment used in emergency systems must be approved for the specific application. Finally, always consult with a qualified electrical inspector to ensure that your installation complies with all applicable codes and regulations. The electrical inspector can provide valuable guidance and can help you identify any potential safety hazards. By following these guidelines and consulting with qualified professionals, you can ensure that your electrical installation is safe, code compliant, and reliable.